All right, so we're going to talk about solving a quadratic equation with complex roots. First off, let's identify the definition of a root. In a nutshell, a root is simply a solution, okay? Specifically, we're looking for a value for x, all right? That's what we want to have. So the value for x would come from an equation that would look like this, okay, or something similar, obviously. And what we're trying to do is we're trying to find out what these x values are such that when we plug those in, we would get 0 equals 0, okay? That is the goal of finding a root. So again, a root, nothing more than a fancy name for what's the solution. Now, because this says a complex root, we know it's going to be of the form a plus bi. It's going to have this imaginary piece because that's what makes it complex. Puts it into the complex plane. All right, which is basically the same as the real numbers, but it has this additional imaginary piece to it. All right, don't worry about that terminology, just know that it's there. Let's go back to x squared plus 5x plus 7 equals 0. Well, when I look at this, I might start, I'm going to have to run through a sequence of testing to see what is going to be the best option here. I could start off by trying to do some factoring, but the issue is this is 1 times 7, this is x and x, and there is no combination of 1 and 7 that's going to lead me to 5. Okay, so I know factoring is not going to be an option here. Another option might be completing the square, right? We could probably try that. But 1 second, sorry. We could probably try completing the square. The issue is though, if I take this 5 and I divide that in half, I'm going to get 2.5, and then I have to square that. It's just going to make for a really goofy situation with the decimal. So not really wanting to do that one either. So completing the square doesn't seem to be a good option for this as well, this either. So that kind of leaves us with the quadratic equation. Now, here's the thing. Typically, not always, but typically, when you're trying to find a complex root, quadratic equation is more than likely going to be your easiest route. So I would just make sure you're really familiar with that equation, really get it into your head. You can rhyme it to the skunk in a barnyard song where it's negative b plus or minus the square root of b squared minus 4ac all over 2a, and so that's all going to equal x. Now the reason for that is, again, the human mind, it just if you have a little tune to it, it does make it a lot easier to memorize. Okay, so with that, we're going to take this quadratic equation. And what we've got to do is we've got to identify a. Okay, so there's a, which is just going to be 1, because there's always a coefficient of 1 that sits in front of a variable. Here's our b. Okay, so that's b. That's a. And we're going to need our c, which is our constant, right? So we're going to take the a, b, and c, and we're going to plug them in. So we're going to have a here and a here. Our c will go here, and our b, there it is, we'll go here and here, okay? By the way, just as a quick side, everything underneath the sign, the square root, okay, is called the discriminant. I don't think I'm going to spell that right, but it's discriminant, okay? And that will come into play over time, in that you can use it to determine whether you have complex roots, one root, or non-real roots, okay? So we'll go ahead and deal with that later. So right now, we're going to go negative 5 plus or minus the square root of 5 squared minus 4 times a times c, all over 2 times a. So this leads us to negative 5 plus or minus the square root of 25 minus 28, and there you can see that's where our imaginary number is going to come from, because I'm going to have a negative underneath the square root, and that's going to create an issue in terms of real numbers. I'm just going to slide this up. Now we're going to go -5 plus or minus the square root of -3 all over 2. Because the square root of -3, I can break it apart into square root of -1, square root of 3, all over 2. By the way, I'm hoping you're noticing that this process that I did here from here is the same as the previous two problems, where when we had the square root of 32, it became 4 times 8, and we square rooted both by using this rule when you have a to the m, a times b to the m, it's a to the m times b to the m. Again, all this stuff, it keeps rotating around. You're just using it in different ways every single time. We know, coming back to -5 plus or minus the square root of -1 times square root of 3 all over 2, we know that for square root of -1, that it will just simply equal the imaginary I, a letter I. And so we'll scroll this up. It's going to be -5 plus or minus I square root of 3 all over 2. At this point, you can just leave this as such, or you can break it into -5 plus I root 3 all over 2, comma, -5 minus I root 3 all over 2. And so these are your two options for answers. You could also divide out the 2. I don't recommend it. Just leave it looking like this. This is a much more accurate version of this answer.